Welcome to the Basic Chemistry Review video. The purpose of this video is to prepare you for the upcoming Basic Chemistry quiz in science class. My name is Mr. Phillips, and I'm going to guide you today through two sections. First, we'll look at the graphic organizer that shows how matter is organized, and then we'll take a look at the periodic table homework worksheet and go over the answers to the questions on that. Let's get started with our graphic organizer. Chemistry is the study of matter, so we're going to put matter here at the top. Matter was discussed in one of our classes, and it can be divided up or classified into two categories, substances and mixtures. Let's start over at the substance side. If your chemical is pure, meaning all the particles in the chemical are the same, you can't reach in and pull out the different ingredients, then you have a substance. And substances come in two varieties. Very simple substances are called elements, and these are listed on the periodic table. You researched an element for your poster. Compounds, on the other hand, are the other type of substance. These are a little more complicated. Compounds have two or more parts that are all bonded together. When we looked at our models of blocks, these would be the blocks that were taped or glued together. One single piece of a compound is called a molecule, and that molecule can contain anywhere from two different elements up to an infinite number of elements. Elements, on the other hand, come in single pieces called atoms. Now, eventually, you could break down a compound not only into its separate molecules, but eventually into atoms. But this step here would require a chemical reaction. You couldn't simply just take the atoms in a molecule and hand pick them out. You would actually have to have a chemical reaction to break them down. So it would be accurate to say that all matter is made up of atoms. However, sometimes those atoms are separate, which gives you an element. And sometimes those atoms are bonded together to form special molecules. In that case, you have a compound. But once again, everything on this side of the chart, this is all pure substances. If, on the other hand, you have a couple different elements or a couple different compounds or some elements and compounds all mixed together in a material, then you have a mixture. In this case, the elements haven't bonded together, the compounds haven't bonded together. They're just sitting together in the same container. So in that case, you get a mixture, and as you can tell, you could have almost an infinite number of mixtures, considering you can combine all the different elements with all the different compounds in different amounts. So that's our graphic organizer showing how matter is classified. Keep in mind, as you go further down this table, down this chart, the matter becomes more and more specific. Now let's take a look at the periodic table. If you would please make sure to have your periodic table worksheet out at this point. Feel free to pause the video if you need to get that. And we're going to go through the answers to your periodic table worksheet questions. Starting with number 1. If you were to look at the periodic table and look at the elements in period 4, how does the state of matter change as you move to the right across the row? Well, period 4 is going to be 1, 2, 3, 4 rows down. All right, so we're talking about this row here, and as you move to the right across this row, so going in this direction, what happens to the state of matter? The state of matter is solid, liquid, gas, or plasma. They want to know what happens to the state of matter as you move across this. Well, as you're here in the metals, these are all going to be solids, and then eventually you get into a liquid over here in the nonmetals, and it ends with gases. So to answer number 1, you would say in period 4, the state of matter changes from solids to liquids to gases. It goes through all 3 states of matter. And the reason they chose period 4 is because of that specifically, that it switches through all the states of matter. Let's take a look at question 2. Name 2 scientists who developed the periodic table and compare and contrast their versions. Well, there were 2 main scientists that worked on the periodic table, Moseley and Mendeleev. And the difference was the way they put the chemicals, the elements, in order on the periodic table. And if you looked in your textbook to answer this question, you would have seen that the periodic table started by being in order by atomic mass, which is that long decimal that you see in each square of the periodic table. Eventually, however, it was changed and they used the atomic number, and that's the system that we still use today. You do not need to know which scientist proposed which for the periodic table. What you do need to know is that the current periodic table is based on the atomic number, and that's why it starts with 1 with hydrogen and goes up steadily from there. Question 3, using different colors, show where the metals, nonmetals, and metalloids are located on the periodic table below. Well, in order to do this, you would need to find out where it divides. And so you want to find where the stairs would be. The stairs start with boron and then go down the periodic table, as you can see here. The elements that are actually touching the stairs are your metalloids. So that would be the ones I'm coloring in here. An exception would be aluminum here. Aluminum is a metal. So if you look at the periodic table, the rest of the periodic table, you have metals on this side of the periodic table, and this corner is going to be your nonmetals. And then once again, they're divided by the stairs, and the elements that are sitting on a stair or directly under a stair are your metalloids. All right, next, let's take a look at this chart. Complete the chart below based on the periodic table. So you have a variety of elements there to look at, and it's asking you what type of element is each one. Iron is already filled in for you. It's a metal. Lithium is going to be on the left side of the periodic table, so that's also going to make it a metal. Boron sits on the stairs, so that means it's going to be a metalloid because it's going to be on those stairs. Cl is chlorine. That's going to be a nonmetal. Silicon sits on a stair once again, so it's going to be a metalloid. Sodium is on the very left of the periodic table. Remember, if it's to the left of the stairs, it's a metal, and so on. I'm going to let you complete the rest of this. Once again, keep in mind, if it's to the left of the stairs, it's a metal. If it's on or below one of the steps of the stairs, it's a metalloid. And if it's to the right of the stairs, it's a nonmetal. Number 5, design and complete the table below. Fill in the headings of each column and then fill in all the blanks on the chart. Well, if we take a look at it, silver is the example I gave you. Silver is 5, which means that we're looking at the period for silver to be 5. So this column is going to be the period. Your next column, 11, indicates the group that silver's in. The next column says metal. Well, that's going to be the type of element or the category. We'll say type. And the last column says that silver is a solid. Well, that's describing its state of matter. So then if we go to hydrogen, hydrogen is going to be in period 1. If we look back at our periodic table, hydrogen is period 1. It's also group 1 because it's in the first row, so the first period. It's in the first column, which is the first group. So period 1, group 1. It's to the left of the stairs, so that would normally make it a metal, but hydrogen is an exception. Hydrogen is a non-metal. And for its state of matter, depending on the periodic table you use, there should be something to show that hydrogen is a gas. We go to lithium. Lithium is also up in that top left-hand corner, but this is going to be in period 2, the second row. It's still in the first column, so that's group 1. It is a metal because it's to the left of the stairs. And your periodic table should show that it is a solid, like most metals. Let's do one more. CO is cobalt. And if you look at CO on the periodic table, it's number 27. It's going to be right in the middle of the table. It's going to be in period 4, group 9. It's to the left of the stairs, so it's a metal. And it is a solid like most metals. The only exception to metals being solids would be mercury. Mercury is a liquid at room temperature. Let's move on to number 6. What element is contained in each of the substances above? Well, the first step is to figure out what elements are what. So this first compound here, this first substance, has a C and an O. C is for carbon, O is for oxygen. Let's check the next one. This one has a C also, but there's a lowercase a after it. That lowercase a is very important because that means we're not looking at carbon. We're looking at an element whose symbol is Ca, which is going to be calcium on the periodic table. It also has a C by itself here, so that's going to be carbon. And then there's an O with a little 3. We could ignore the 3. The O tells us that there's oxygen there. We'll learn about the 3 in a future unit. So we've got carbon, oxygen. This one has calcium, carbon, oxygen. Here we have a C again for carbon, an H for hydrogen, and finally we have an H for hydrogen, a C for carbon, an H for hydrogen again, and an O for oxygen. So if you look at all of those, the element that's contained in all of them is going to be carbon. Each of the 4 substances above is an example of a blank. Well, let's go back to our organizational chart. Said each of those is a substance. So if we look at our substances, they can be either an element or a compound. An element is made of individual atoms. A compound is made of molecules. So if we look at our choices here, each of the 4 substances above is an example of a blank. Well, I see 2 different elements here, so it can't be an element. If you have 2 or more elements together, that's going to have to be a compound. And then finally, which of these substances contains a metal? Well, let's look at our elements again. Carbon is a nonmetal. Oxygen is a nonmetal. They're both to the right of the stairs. Calcium is to the left of the stairs, so that's going to be our metal. So which of these substances contains a metal? Well, you would have to say CaCO3. Oops. All right, CaCO3 is the only one that contains a metal up there. That's because calcium is to the left of the stairs and it's not hydrogen. Number 9, which type of element did you research for your poster? What are some other elements, examples of elements in your area of the table? So in this case, whatever element you had, you needed to name that element, and then you need to talk about elements that are in the same area of the table. So you could have, if your element was a metalloid, you could have named other metalloids. If it was a nonmetal, you could have named other nonmetals. And if it was a metal, you could have named other metals. Any of that would have been acceptable. Number 10, name 2 methods scientists use for naming newly discovered elements. Keep in mind this question is not asking how did they come up with the symbol. They wanted to know how were they named. And some of the most popular ones were to name them after locations, such as Californium, or you could name it after scientists, or you could even name it after Greek or Latin words. So those are some of the ways, and there are lots of examples of those ways being used on the periodic table. Well, that concludes our review video. Feel free to watch it again, rewind. There is a practice quiz on Castle Learning. It's 10 questions. It's a good way to see if you are done studying or if you need to study some more. Feel free to come in and compare your T-cards to Mr. Phillips's own set of T-cards to see if you left off any facts. And once again, as usual, stop by and ask for help if you need it. Thank you very much, and I'll see you in class.